Leetcode problem number 1, the two-sum issue. So I am the kind of guy who really likes to not say this is an easy problem, because for some people it may not be easy. And for me, when I first did this, it was not easy. So going through this, I'll kind of use an approach that's not the most time complexity efficient as far as like a big O notation, but I'll use an approach that is easy to understand so that we can kind of see how things might look. So the problem goes like this. Given an array of integers, nums, like this, an integer target, this, return the indices of the two numbers, so the indices of the two numbers in here, such that they add up to the target. So whatever numbers here, we're going to return the indices of whatever adds up to the target. You may assume that each input would have exactly one solution, only one valid answer exists, and you may not use the same element twice, meaning you can't use 7 and 7 if it was like 14 or something like that. And you can return this answer in any order. So right here we see that we get 2, 7, 11, and 15 with target of 9, and the output is 0 and 1, which means that num sub 0, num sub 1 add up to 9, so 7 plus 2 is obviously 9. We can see the same thing with the second example, 3, 2, and 4. 4 and 2 add up to 6, so it returns 1 and 2, so the array sub 1, the array sub 2. And then nums 3 and 3 add up to 6. So the constraints, the length of the array is anywhere from 2 elements all the way up to 10 to the 4th elements. And the target can be really small or really big. And then same with the any of the elements that are put in the array. So only one valid answer exists. So I'm going to use a brute force approach, which will end up being O of n squared, because I'll be using a nested loop. It seemed the easiest at the time when I first did this problem. So it means that essentially I'll use one loop that goes over each array, or each element of the array, at the same time that another loop inside of the first loop is going over each array as well, each element of the array as well. So first I'll go with 2, and then the inner array will go for 7, 11, 15, and then the second one will go 7, 11, and 15, so on and so forth. So and then I'll have a conditional statement that will ask if these two elements that we have ready equal 9 or whatnot, it will return those indices. Otherwise it'll just increment through each of the elements of the array. So I'm going to instantiate two counters. I'll do a slow counter that represents the outer counter. Oops, my goodness. And then I will also instantiate a fast counter that will represent the inner counter. Now I'm not instantiating it now, and you'll see why in just a second. So first we have a while loop that says while the slow counter is less than the length of the array minus 1, we will go through and instantiate the fast counter. So the reason why we're doing this is because you may not use the same element twice. So as we go through this loop, essentially it's going to go through a counter and we'll end up incrementing that slow counter, but the fast counter can't equal the slow counter, which means that once we instantiate it, it's got to be something else other than 0 as we go through so it doesn't use that same element twice. So if we're at 0 for that slow counter here, the fast counter can't also equal 0, it has to equal 1. So what we're going to do is do slow counter plus 1. And then we can go into our while loop for the fast counter. So fast counter less than nums.length. I'll fix that one up there. Nums.length. So since this is 0 and this is 1, 0, we'll just do subtract 1 to go to the end of the array, or else we'll go over the bounds of the array. And this one, since this is 1, we will not go over the bounds of the array if we just do the length of the array. So we'll just keep that there. So when we go to the second one, we'll just do a conditional statement for each one of these that says if the slow counter, if nums sub slow counter plus nums sub fast counter is identical to target. Identical and equal to are different, so identical is much better for many reasons, not explained in this video. That's just much better. So if that condition is true, we're going to return, since there's only one possible solution, we're going to return that solution, not INJ, slow and fast counter. Otherwise, we will increment the fast counter and then once we've gone all through all those, we will come back out and increment the slow counter. And if we go through all the different pieces of the array, we can return an empty array if there's no solution. So go ahead and run it. Looks like we've accepted with those 3 test cases, and then we'll submit it. And it was accepted. And as you can see, not a super great approach as compared to other approaches that you can use with a hash table, but a good solution nonetheless. If we analyze complexity, it'll probably tell us it's O of n squared because of the nested loops. So as n, which is the number of elements in the array, if n gets bigger, then n will be increasing at a exponential rate because it will go through n times. So it's n times n, which equals n squared. So there's the solution.